I really love to investigate and find things out. This unit made me think of nature and how it helped us. We first started learning a lot about biomimicry. We became biomimics and coded artificial intelligence to help others.
Biomimicry is a global approach being used by not only scientists, but also engineers, architects, and designers to create a sustainable, sensitive, and more sensible designs in order to solve problems in the modern world. Imagine if we could harness this knowledge and power and put it into the hands of 8 and 9-year-olds. I went on to find out more myself, and I just knew kids would love the idea and naturally connect with its simplicity.
Do you know that biomimicry means copying life? Because the bio in biomimicry means life, and mimicry means copy, so it's copying life. Well, it's when humans use animal characteristics to make new things.
Nature has been around for thousands of years, so we need to learn.
Our aim was to get the students outdoors and solving real-world problems, to not only enrich their environmental literacy, but to also allow for deeper connections, student agency, to develop empathy and become greater global citizens. The knowledge and skills we wanted the students to gain by the end of the unit focused around features and characteristics of places and environments and how people interact with their environment. This led us to the big idea of adaptation and design, with the driving question, how can nature sustain and nurture us? Biomimicry was our answer. 1, it would be deemed so cool by an 8-year-old, allowing strong connection to be made with the unit. And secondly, it allowed us to engage their curiosity, the driving force of this unit, and therefore allowing them to see themselves as biomimics. We began our inquiry-based exploration with some incredible visual literacy texts. These were instrumental in providing real-world examples and scientific explanations, which were only enriched by narrative.
My favourite book is Invented by Animals. I really like how biomimics use the idea from shark skin to create wetsuits. It works so well that it was even banned from the Olympics.
To launch the students headfirst into the topic, we used a strong provocation, which involved them in matching tangible objects with their real-world animal connections. This allowed students to demonstrate their background knowledge and their passions, and helped us to determine the direction of our unit. Next, we looked at how we might integrate this unit into other learning areas, such as reading, writing, and speaking and listening. We comprehended quality texts, listened to educational podcasts, viewed a range of digital material, and became inspired to write from all of these sources. By sharing the UN's mission statement with the students, that the 17 goals are a blueprint to achieve a better and more sustainable future for all, and adopting it as our mantra, they were able to see how important their learning really is. We felt goals 3, about good health and well-being, and goal 11, about sustainable cities and communities, could support us through this learning journey.
With the implementation of a conceptual inquiry framework, we had the opportunity to collaborate and curate learning where students were immersed in a range of experiences focusing on the concept of biomimicry and design. So examples of how we mimic and imitate nature are increasingly influencing product design from health, well-being, architecture, fashion, robotics and engineering. Through each phase of our inquiry framework, we use guiding questions, case studies and hands-on discovery, where students explore the mechanics and adaptations made by animals and insects. So lessons are designed to target specific scientific, technical and design skills, leveraging our students' empathy and appreciation for our natural world. Experiences include excursions to the city and the Botanic Gardens, virtual expeditions of buildings and animal habitats for inspiration, experimenting with those hands-on materials, museum resources, and lessons coding to create and mimic insects and animals. We also accessed experts in biomedicine and architecture to clarify and connect ideas to our research and development of ideas. The use of provocations, case studies and immersive hands-on experiences are pivotal in building that depth of field. Our students are encouraged to wonder, to notice, research and develop their conceptual understanding of adaptation and design. In one of our lessons, we focused on a case study about bats. The students examined how to use echolocation to find and notice their food.
From our science lesson, I came up with the idea to use echolocation with people who have a hearing impairment. I want to use artificial intelligence to identify objects. We've been learning about all of this in our technology lesson.
Running concurrently with this program was a course that focused on robotics, coding, and artificial intelligence. Each week in class, students would take a focus on some type of biomimicry, whether it be with animals or plants. Then students, armed with a McQueen bot, a Husky lens, a microbit, and their iPad, would then use artificial intelligence to create some type of biomimic with the animal or plant they'd been studying. Students came up with fantastic ideas. These real-life applications were so meaningful for students as they could make connections. From cricket thermometers to a light-seeking robot, similar to a turtle hatchling looking for the moon as it makes its way to the water. We made a colour-adapting chameleon.
I taught my McQueen to be like a chameleon using artificial intelligence. It can recognize colours like green, red, and blue.
And a self-driving robot which uses echolocation to avoid any accidents. Finally, students were asked to create their own project. They could use their artificial intelligence lens, their McQueen bot and microbit to create something that would help somebody or something, whether it be an animal or a person they know or in their community. We wanted to ensure that students understood that the devices they would be making could actually be used in real life and will make a difference in the future. To do this, we focused on empathy mapping. We also used scaffolds such as the design framework and of course the inquiry model. Bringing these three elements together really empowered our students and helped them understand and make strong connections. Our students were no longer just students anymore. They were biomimics. They used engineering, robotics, coding, and of course artificial intelligence to create a device that would change something for someone or something. A very, very exciting concept.
We really love animals and we want to help and care for them. We made a device that could help them. One of our favorite animals is a turtle, and 5 out of 6 of them are endangered in Australia. We found out that the feral pigs were eating the turtle eggs before they hatch. We used artificial intelligence and microbit so we can create a device that can scare pigs away. This is the Husky lens. I will show you how to teach it color. First thing you need to do is click this button and aim and put the plus button and aim it at any color you want and it will learn, and the longer you do it will learn more of it. And then it says color ID 1 and then it will say color ID 1 whenever it sees that color and different shades of it. We use biomimicry so we can redesign a new pair of wheels from the crab. The spiky crab legs can walk on sand. And we also use the design of the frill-neck lizard so it can scare away stuff. And we're gonna attach lights and sprinklers onto the skin because we know that those scare away pigs. We use artificial intelligence to teach our bot what a feral pig looks like. We really like to make devices and hope to change the world.